Hey everyone, and welcome. You've probably looked at some crazy AI and just wondered, where does it even begin? Well, it's not magic, it's a process. And right at the heart of that process are some seriously powerful tools in Python. So today, we're going to open up that toolbox and see exactly how a simple idea gets turned into a real deal machine learning model. So that's the big question, right? How do you actually get from a huge, messy pile of data to a smart, predictive system? It's a total transformation. And, like any big project, you've got to have the right tools for each part of the job. So let's break that down, one essential tool at a time. First things first, before you can build anything cool, you have to get your hands dirty with the raw materials. In machine learning, that means data. And let me tell you, data is almost never neat and tidy. So this first step is all about wrangling that chaos. Okay, so let's get into our toolkit. We have to start with the absolute foundation, the bedrock that everything else is built on, NumPy. You can think of this as the raw muscle of our entire operation. See, at its core, everything in machine learning, whether it's images, text, sales figures, you name it, it all gets turned into numbers. And this is where NumPy just completely shines. It's designed to handle these gigantic arrays of numbers and do it super, super fast. It's way more efficient than regular Python because it keeps all that data together in memory. This is the engine that gives us all our computational horsepower. Right, so NumPy gives us all this raw power, but raw power without any direction is just noise. We need a way to organize all those numbers, to give them some structure and context. And that's where the next tool in our kit comes in, Pandas. And this is exactly what Pandas does. It basically takes that jumble of numbers and wrangles it into a beautiful, structured table called a data frame. Think of it like a spreadsheet on steroids. This is an absolute game changer for things like finding and fixing missing values, analyzing columns, and just getting our data prepped and ready for the real work. It's literally how we bring order to the chaos. Okay, so our data is clean, it's structured, that's a huge step. But it's still just a massive table of numbers and text. How do we actually start to understand it? How do we find the story that's hiding inside all that information? Well, it turns out the best way to do that is to actually look at it. The human eye is an incredible pattern recognition machine, but it can't make sense of a million rows in a spreadsheet. So this next phase is all about turning our data into something we can actually see. And to make our data visual, we grab the storyteller from our toolkit, Matplotlib. This is the tool that helps us translate millions of data points into a picture that actually tells a story. And this is so important because Matplotlib lets us see our data through charts and graphs. Suddenly, a scatter plot might show a clear relationship between two things you never thought were connected. Or a bar chart could reveal a trend you just would not have noticed. These are the kinds of insights that are completely invisible when you're just staring at a table of numbers. Now, sometimes just looking at charts isn't enough. Sometimes our analysis needs a bit more mathematical heavy lifting. We need specialized tools for some of the more high-level scientific and technical stuff. So for that really tough work, we bring in our next tool, SciPy. It's actually built right on top of NumPy, and it gives us a whole library of advanced algorithms for when we need to go beyond the basics. We're talking serious statistical modeling or complex optimization problems. Think of SciPy as the specialist's toolkit. When you need to do something very specific and very complex, like find the absolute best solution to a problem or run some advanced statistical tests, that's when you open this box. SciPy has these high-performance modules just ready to go. Okay, we've finally reached the last stage. We've wrangled our data with NumPy and Pandas. We've explored it and understood it with Matplotlib. We've done any complex math we needed with SciPy. The stage is set. It is time for the main event. This is it. This is what all that prep work has been leading up to. Taking our beautifully prepared data and using it to train a model that can actually make predictions or find patterns all on its own. And for this grand finale, we bring out the star of the show, scikit-learn. This is our absolute go-to library for what we call classical machine learning, which is just a huge range of really powerful models that aren't necessarily deep learning. Scikit-learn is just fantastic because it brings everything together so nicely. It has a massive library of ready-to-use algorithms. It doesn't matter if you need to classify something, predict a number, or group things together. Scikit-learn gives you a simple, consistent way to build, train, and test your models. All that prep work we did, it pays off right here. So let's just quickly recap that whole journey. We started with NumPy to handle the raw numbers. Then we used pandas to give them structure and get them clean. Matplotlib let us actually see the patterns. For the really tough math, we brought in the power of SciPy. And finally, we used scikit-learn to build the actual model. It's a complete workflow where every single tool plays an absolutely essential part. And there you have it, the complete toolkit. We've seen how all these libraries work together, step by step, to turn a simple idea into an intelligent system. So really, the final question isn't about the tools anymore. It's about your ideas. With this kind of power at your fingertips, what problem would you solve first? The possibilities are pretty much endless.